A swimmer is going due east for a distance of 755 meters, turns around and goes to the west for 220 meters, and finally again due east for 355 meters. A. Determine the total distance traveled by swimmer. B. Determine the magnitude and direction of the displacement of the swimmer. So, actually, we have to compare distance and displacement for this motion. Let's assume that at the beginning, swimmer is at the origin. The first part of the motion is due east for a distance of 755 meters. The green vector then represents the displacement and blue line represents distance of this first part of the motion. Therefore, it's obvious for distance to be 755 meters and for displacement to be 755 times unit vector I. Do not forget, displacement is a vector. Similarly, for the second part of the motion, swimmer goes due west for 220 meters. So distance is 220 meters. But displacement in this case is minus 220 meters. At last, we have motion due east for 355 meters. Again, distance is 355 meters and displacement is plus 355 meters times unit vector I. At the end, total distance is 1,330 meters and displacement is plus 755 minus 220 and plus 355, which gives plus 890 meters times unit vector I. So direction is due east and the magnitude is 890 meters. Let's see again the full motion. It is obvious that the only thing one need to determine the displacement is to know initial position and final position. Displacement is denoted with the red vector.